Today, Rob McNelly asks, why do I want to run PowerVM? As we go through this quick presentation today, I want you to ask yourself questions about your current virtualization solution. I want you to ask yourself, can my virtualization solution do that? With PowerVM, I can define an LPAR using only 1/10 of a CPU. After the LPAR is running, I can even control the CPU down to 1/100th of a CPU. Can your solution do that? I can run multiple VIO servers on my single physical computer. I can isolate networks and disks on logical and physical levels. I can create shared processor pools, shared storage pools, and I can thin provision my storage. I can do live partition mobility operations where I move running workloads from one server to another, and I can use tools like active memory sharing, active memory expansion, and active memory deduplication. There are several places you can go online for more information about all of these topics, an example of which I will show now. When I Google for PowerVM Active Memory Expansion, I can click on the Dare to Compare virtualization link and get a great deal of information about this topic. Let's take a quick look at our virtual machine maximums. Maximum virtual CPUs, 256. Memory per virtual machine, 8 terabytes. Running virtual machines per server, 1000. CPU threads per server, 1024. Memory per physical server, 8 terabytes. You can give all of the memory and CPUs on a physical system to a virtual machine if you wanted to. What kinds of operations can we perform on a running system? We can dynamically change our CPU. We can dynamically add and remove memory on a running LPAR. We can dynamically add and remove I/O devices. We can have virtual devices or physical devices or mix and match them. We can make changes to our I/O on the fly with a running system. This is one simple example. I have a running LPAR with 4 gigabytes of memory on it. I will add 2 gigabytes on the fly. Then I will remove the same 2 gigabytes on the fly to bring me back down to 4 gigabytes. As I make these changes to my running system, ask yourself, can you add and remove memory and CPU resources like this on the fly with your current virtualization solution? Can you dynamically add and remove I/O devices? Can you change from virtualized adapters to physical adapters and back again depending on the needs of the business? We have two options when it comes to managing workloads with PowerVM. We can move resources to the workload by dynamically adding CPU, memory, or I/O devices, or we could pick up our running virtual machine and dynamically move it to another physical machine using live partition mobility. PowerVM is embedded in the firmware. It is not a third-party application that I need to download and install. It is always running on my system. It was built by the same people that made the CPU and made the server. We can perform live partition mobility operations across processor generations and across the server family. I can move from Power 6 to Power 7 and I can move between models. Maybe I need to move to a more powerful server or a less powerful server. This can happen seamlessly on a running machine. With IBM Power Systems, the same company builds the processor, builds and designs the servers, and integrates their virtualization solution into the overall system architecture. Be sure to take a look at your server's performance benchmarks, see how they stack up. Then ask yourself, was my server virtualized when those benchmarks were run? IBM Power servers were. The virtualization is embedded. All benchmarks are being run on virtualized servers. If you were to try to run your benchmarks on a virtual server, what kind of overhead and penalties would you incur? Check out this website for more information. Now ask yourself, why aren't you running PowerVM?